Hello, welcome again. We are solving GATE 2021 Aerospace Engineering paper. Question number 53 is an airplane weighing 5500 kg is in a steady level flight with a speed of 225 meter per second. The pilot initiates a steady pull-up maneuver with a radius of curvature of 775 meters. The location of center of gravity CG, center of pressure of on wing CP, and point of action P of tail force are marked in the figure. Use G is equal to 9.81 meter per second square. Neglect drag on the tail and assume that tail force is vertical. Assuming the engine thrust and drag to be equal and opposite, the collinear tail force is dash kilonewton. Round up to one decimal place. So this is your aeroplane and this is your CG, this is your CP, and this is your tail force acting downward. Okay. So force acting on aircraft is forces acting on aircraft is first of all is its weight, that is W 5500 into 9.81, that is 53955 Newton. Okay, as it is rotating like this, okay, rotating like this, pull over maneuver. Okay, so and its radius is 775 and speed is 225 meter per second. So the centrifugal, it will exert a centrifugal force that will act in a direction uh, same as that of weight. Okay, as it is rotating like this, so F will act in this direction. Okay, so centrifugal force, and this centrifugal force is 550 225 square by 775, so that is 359 274.19. So and suppose T is the tail force. Okay, here tail force is acting. Suppose T is your tail force. Okay, and because it is pull over maneuver, so that is why it is rotating like this. Okay, so T is tail force, and taking moment about center pressure, because center pressure is the point where all the forces are assumed to be acting, at which at that point there is no moment. So taking moment about center pressure, so W will act like here, and F will also act here. W plus F into 20 is equal to T into 550. So W plus F, W we have found out and F we have found out. Now only missing thing is T, so T comes out as 15.026 kilometers. Next, a jet aircraft weighing 10,000 kg has an elliptical wing with a span of 10 meter and area 30 meter square. The CD note for the aircraft is 0.025. The maximum speed of aircraft in steady and level flight at sea level is 100 meter per second. The density of air at sea level is 1.225 kilogram per meter cube. Take G is equal to 10 meter per second square. The maximum thrust brought by the engine at sea level is dash Newton. So dynamic pressure is 1 by 2 rho infinity V square. So rho is your 1.225 and V is your 100. Okay, so dynamic pressure comes out as 6125 Newton per meter cube, and lift is load into G, sorry, weight, mass into G. So mass is your 10,000, so and G is we have to use the 10, so that is the lift, and lift is equal to weight. So and CL, coefficient of lift, is L by Q infinity into S. So that is 100 into 1000. Okay, and Q infinity is your 6125 and this is your 30. So CL is your 0.5442. So coefficient of lift is 0.5442. Okay, and from this coefficient of lift we have to find out the induced drag coefficient. So CL square divided by pi E AR, and E is your 1 for elliptical wing and AR is your aspect ratio. Aspect ratio is B square by S, so that is 10 square by 30. or 10 by 3. Okay, so CDI comes out as 0.02828. Now coefficient of drag is CD naught plus CDI, that is induced drag plus CD naught. Okay, at 0 degree 0 degree at of drag plus at induced plus induced drag. So CD comes out as 0.05328. Okay. So now as we have no CD, so we can find out drag, that is Q infinity into area into CD. So drag is 9790 Newton. So drag is your 9790 drag at sea level, because thrust and drag are equal. So that is drag and thrust are equal at sea level. Okay, so answer is 9790. Drag and thrust are equal, so that's why answer is 9790, because the thrust has to overcome that drag and it is moving at a uniform velocity. Okay. Next, consider a jet transport airplane with following specification: lift, curve, slope. Okay. Next, 55. Consider a jet transport airplane with following specification: lift, curve, slope for wing body. Curly CLWB by curly alpha WB is 0.1 per degree. Lift, curve, slope for tail. Curly CL L sorry T curly alpha T is your 0.068 per degree. Tail area ST 80 meter square. Wing area S 350 meter square. Distance between the mean aerodynamic centers of tail and wing body L bar T is 28 meter. Mean aerodynamic chord C bar is equal to 9 meter. Down wash epsilon is equal to 0.4 alpha. Axial location of wing body mean aerodynamic center XC by C bar is 0.25. Axial location of center of gravity XCG by C bar is equal to 0.3. All axial locations are with respect to the leading edge of the root chord and along the body x-axis. Ignore propulsive effect. The pitching moment coefficient curve slope Cm alpha is dash round up to 3 decimal places. So that the pitching moment coefficient of slope is given as this curly Cm CD by curly alpha is A H minus HAC wing minus minus VH AT by A bracket 1 minus curly epsilon by curly alpha. Okay, so this here A is your curly CL by curly CL wing by curly alpha. So that is 0.1, and H is your HC by C, that is also given, that is 0.2. HACW is XC by C bar, that is 0.25. Volume ratio is LT/ST, but that is volume at tail, and this is CS. Where LT is the distance between the tail aerodynamic center and center of gravity. Because this here L bar is given, that is the distance between the tail aerodynamic center and the chord and wing center. So that distance is 0.3. So we can find out this LT. So LT bar minus C, H minus HAC, that is H is 0.3 and this is 0.259. So now from this we can find out the distance between tail aerodynamic center and center of gravity. Okay. Now we can find out VH. Okay, and this is 0.068 and this is, yes. So by putting this value we can find out CM.